Let's talk about principles of motion and stability for Chapter 3. Development changes are predictable. They're based on optimizing biomechanical principles of motion and stability over time. They can be seen across a variety of motor skills, and they often produce more force, velocity, or accuracy. Motion and stability. Developmental changes in movement occur according to the biomechanical principles. Motion and stability are two principles within the larger field of biomechanics, and motion and stability are known as the physics of movement. What changes from A to B? Newton's first law. An object at rest stays at rest, and an object in motion stays in force until acted upon by a force. Inertia is a resistance to motion related to mass, and momentum is a product of mass and velocity. Newton's first law simplified. 1. We must exert force to move objects or ourselves. 2. More inertia means that it is harder to move. More force application is required. Newton's first law. Child learns to swing a bat. What must a child learn about inertia? What must a child learn about momentum? To move an object farther or faster, you need to increase your force delivered to the object or increase distance over which force is applied. Adding distance to improve a kick. We either need to increase step length or increase range of motion, rotational distance. Newton's second law, object's force is related to mass and acceleration. Object's acceleration is related to force and applied inversely related to mass. People can throw only as hard as they can throw. Given this peak force level, how could you increase acceleration when throwing a ball? Newton's third law, to every action there is an equal and opposite reaction. When you push on something, it pushes back at you. Let's use oppositional movements and directional force. Let's look at these videos. We can also exert force in primary movement plane. Use force in the plane of motion in which you want to move yourself or an object, and you can avoid rotational movements that reduce force in the desired plane. Let's watch this video. Increasing velocity, rotated limbs and projected objects. Increase rotational velocity, swing it faster, or increase the relative length, fully extend it at release or contact. Why not keep limb extended through movement? The leg would have too much rotational inertia. Let's look at these videos. Force and time. To make an object move, increase force application for a given time. Example, karate chop to bricks. To make an object stop, increase time over which a given force is applied. Example, soft landing in gymnastics. Question, what developmental skills involve learning to absorb force? Stability and balance. Stability, ability to resist movement. Balance, ability to maintain equilibrium, and stability, mobility trade-off. Increasing stability, increase the base of support and lower the center of gravity. Increasing balance, increase stability, improve strength, coordination, and proprioception. Here's a summary and synthesis of this chapter. Number 1, motion and stability are two principles of biomechanics that act as constraints that govern how an individual interacts with the environment when performing a task. Number 2, an understanding of movement experiences with motion and stability can lead to better control and performance of motor skills. And number 3, stability and balance are two mechanical principles involved in efficient and skilled movement.